Okay, fifth graders, I've got some math here for you guys to do. I want you to do page 49, 50. Oh, there's no talking in here, gentlemen, or you're out. And 51. So we're going to start with page 49. And let's take a look at this here. It says an amusement park has two roller coasters. One is 628 feet long. The other is 485 feet long. If you ride both roller coasters, about how many feet will you travel in all? Now here's the key word. This section is about estimating. And when you estimate, you're not getting exact numbers. So I'll just give you an example. If I wrote down 209, and we're going to add 598. And I wanted to know what that is. And I said, just to give me an estimate. Well, it's pretty easy. 209 is really close to 200. 598 is really close to 600. Add them together, what do you get? 800. So when we estimate, you're not necessarily, in fact, you're not getting an exact answer. You're just getting in the ballpark. So let's look at these two numbers they gave us here. One is 628 feet. Well, what's that kind of close to? Well, that's close to 600. And then the other one is 485 feet. What's that close to? That's close to 500. 500 and 600 together, we're talking about 1,100. 1,100. So that's estimating. So it's really kind of easy. Now, in this book, and in some things that we estimate, they don't tell you how close they want you to estimate all the time. Here's what I mean. Let's look at this same problem again here, 628. Maybe they want you to estimate to the tenths, not tenths, sorry, to the tens place. So this is closest to, if we went by tens, 630. And then 485, okay, if we went by tens, so we're going to have to round, and this is a 5 or larger, so this would become a 9, so this would be 490. And then you would add them up. And so the trick is, I kind of looked ahead, they're not always clear as to how much they want you to estimate, how close of an estimate, by tens or by 50s or by hundreds. So we'll just kind of work through this. But anyways, estimating, that's what we're looking at here. And so about how much longer is one roller coaster than the other? It says show your work. Oh gosh, if you were copying down what I wrote, you can just draw a little arrow, and we've really kind of done that. So how much longer is one than the other? I'm going to go with my first two here. One was 600, one was 500, and I'm just going to say about 100 feet. Now I'm going to show you a symbol for about. You don't have to write the word about, just go like this. A little wiggly line means about, and I'm going to put 100 feet. Make sure you put feet. All right? So that little symbol means about. All right, next page. Okay, says here, students are collecting dog food to give to an animal shelter. So my daughter-in-law works at an animal shelter. Estimate how many pounds were collected in weeks 3 and 4. All right, well, that's not too hard. Here's week 4, here's week 3. So it says to estimate. So it's not telling us how detailed they want us to estimate. Do they want us to estimate by hundreds of pounds? By tens of pounds? By 50 of pounds? I have no idea. It doesn't say. But if we go down to one way here, it does say round each add in to the nearest hundred. So that tells us that information. But up at the top, it wasn't that specific. And you can see what they did here. 237.5, that rounds, that's closer to 200. 345.1, that's closest to 300, so 500. So it's about 500, or you could write, like I said, a little squiggly line. If you just wrote 500, I would know what that meant. So the students collected about 500 pounds of dog food in weeks 3 and 4, okay? Now there's another way you can do these. It says substitute compatible numbers, all right? So let's look and see what they did here. 237.5, okay. That's closest to 250. In other words, 237 is closer to 250 than it is 200. 345.1 is closer to 350 than it is 300. And so you add those together and you get 600. So compatible numbers are numbers that are easy. I'm going to write this down here. Easy to add or subtract together. All right, that's compatible numbers. All right. But again, they didn't tell us to go necessarily by 50s or hundreds there. So again, that's kind of a complaint of mine on this particular lesson. They're not always specific enough for my taste. Let's look at the bottom here. It says, Thomas said we did great in week 4. We collected just about twice as many pounds as in week 1. Use estimation to decide if he's right. Explain your thinking. Okay, well, let's look over here. We're comparing week 4 and week 1. Here's week 4. Here's week 1. So week 1, are we rounding by hundreds or by 50s? Well, they don't tell us. So let's go by 50s. So 172.3 is closer to 150 than it is 200. And in this one, 345.1, that's closer to 350. All right? And so twice as many, is that what he said? Yeah, twice as many as in week 1. Well, let's go back. Week 1, 150. What's twice 150? So 150, I'm going to write that down here, 150 plus 150. If you could do that in your head, you know it's 300. And he said about twice as many. In week 4, I had, week 4, I'll write that down here, equals 350. So use estimation to decide if he's right. Well, gosh, question mark. Is he right? Well, yeah, it depends on how detailed you want to be. So, again, these kinds of lessons I have a hard time with because, how much leeway do you give a student and how far off can they be? So I would say he is about right. All right, if we're using estimation, fine. We can say he's about right. All right, so let's go over here. Page 51. What do we got here? You can estimate the differences. Estimate 22.84 and 13.97. So here's our example. One way, round each number to the nearest whole number. The nearest whole number, so that's the ones. So 22.84 is closer to 23, so we've done that. Or they've done that. 13.97, that's really close to 14. And it did say estimate the differences. Remember that. When you see the word difference, we're talking about subtraction. Always remember that. So we go back to this one, the example they gave us. Notice that they're both subtraction. So the difference is about 9. Now, here's the other way that they suggested to substitute compatible numbers. Same thing, 22.84. So that one's, they just called it 25. Because doing something with 5s is much easier. Those are compatible numbers. All right? Any numbers that end with 5, it's easy to work with them. So 25 subtract 15 is 10. So it would be about, about 10. So they just kind of gave you a couple examples there. So let's see here. Yeah, let's just do this page and we'll call it a day here. So in the example above, which estimate is closer to the actual difference? How can you tell without subtracting? Well, let's see here. What is the actual difference? I guess we'll have to figure that out. The actual difference. So we're going to put 22.84 and we're going to subtract 13.97. Notice how I lined up my decimals? You guys should know that automatically by now. 7 from 4, we can't do that, so that becomes a 7. 4 becomes 14. That's subtracting 7 leaves 7. 9 from 7, well, we can't do that, so we're going to have to borrow 1. That becomes a 1. This becomes 17. So 17 from 9 is what? 8. Decimal. Put that down so I don't forget. Oh, we have to keep borrowing here. 3 from 1, can't do that. That becomes 1. That becomes 11. What do we have left? 3 from 11 is 8. So 8.87 is the actual, I'm going to underline there, the actual difference. And the question is, which estimate is closer to the actual difference? Well, is 8.87 closer to 9, or is it closer to 10? Well, it's actually closer to 9. See, closer to 9. Oh, and I just noticed, look at that. How can you tell without subtracting? Well, gosh, what do they have here? The rounded numbers are closer to the original numbers than the compatible numbers. And it doesn't say how you can tell without subtracting, so I'm not going to worry about that. I'm just going to scratch that out. I just automatically want to subtract and get the answer. Number 2. In the example on the previous page, students collected more pounds of dog food in week 4 than they had in week 3. Estimate about how many more. So how many more in week 4 than week 3? Let's go over here. They don't tell us how much as far as how close we need to get. So week 4, 350. Week 3, well, I would round this maybe to 340. It's closer to 340. So 350, 340. So what is that? About 10 pounds. About 10 pounds. Notice I'm labeling that number. I'm not just putting 10, or I'm not just writing about 10. I'm putting 10 pounds. So I know what we're talking about here. We're not talking about, 10 pieces of candy, 10 students in my classroom, 10 Chromebooks. Talking about 10 pounds. It's important that you guys label those. All right, and 3 through 10, estimate the sum or difference. Now, sum, what's that mean? That's addition. And I said earlier, what's difference? Subtraction. So some of these are subtraction and some are addition. So don't get in the habit of just suddenly, assuming they're all addition. So here's what I would do. Well, again, I don't know how close they want us to estimate because they don't tell us. But I think 49, I'm just going to call that 50. 22.88, well, let's just call it 23. I'm going to scratch those out. Let's go to 4 here. 86.9, that's closer to 90. Let's just call it 90. 18 is pretty close to 20. Let's call that 20. You can kind of see what I'm doing here. 179, that's close to 180. 277.1, well, that's close to 280. All right, and we're adding and we're subtracting those two. 23.2, I don't know, that's I suppose if we just went with whole numbers, we could call that 23. 9.71, that's close to 10, and we're subtracting. So it's kind of, I've never been comfortable with estimating because I don't know how close should tell my students to estimate. That's kind of why I'm doing these myself right now. 23.8, that's close to 24. Minus 4.7, that's close to 5. 87.2, well, that's close to 90. Adding 3.9, well, that's close to 4. 38.9, well, I'm not going to do those. I'm going to let you guys figure those out. Let you estimate how close as you want. We'll check tomorrow. So it does make it a lot easier. It's just not very accurate. Maybe that's why I just like it so much. It's just not very accurate. Well, 11 through 18, down here at the bottom, if I can get that to reach, I'm going to have to set my scope up here. Those are the same kind of problems. 79.1, that's a no-brainer. I'm going to make that 80. 80 plus 32.4. I don't know, let's just call it 30. Maybe somebody would write down 32 instead. Oh, there's the phone ringing, but I'm not going to answer that because I'm doing a video. All right, 788.9. Don't bother to answer it, honey. It's okay because I'm not going to pick it up. 788.9. Well, let's just call that 800. It's pretty close to 800. Minus 572. That's close to 600. And you can see what I mean. I mean, this, somebody else might say 790 instead of 800. Who knows how close they want us to be. So let me do one more here. 837. Well, let's just call that one 840. Plus 488. Let's call that 490. All right. So I'll let you do 14 through 18 on your own, and we'll just kind of check to see how you rounded them, what did you use for an estimate. And what's nice about this, and I'll put a smiley face here, is that there can be more than one right answer depending on how you estimate. You know, I mean, if you estimate incorrectly, like look at 17 here for a second. If somebody says 8.1, I'm going to call that 5. Well, there's no sense. That doesn't make any sense. Why would you call 8.1 5? And 3.7, they're going to call that, 1, and 7.9 3. I mean, there's no reason. There's no rhyme to that at all. It doesn't make any sense. Okay? So, anyways, that's it. I'll see you guys tomorrow.